Now, sometimes we're asked to graph the inverse of a function without knowing the equation. So if they give us the graph, the best way we can do this is find specific points on the graph that we are clear, well, I guess we have a clear idea of what they are. And so you'll notice that I have the function, I guess I'll call it f. And we see that we have clear points marked. They're in green. Now, if there were no clear points marked, you'd have to find some just to make sure that they actually have coordinates, so you're not estimating anything. So for f, what I'll do is I'll just list the ordered pairs just so that we can see them. So ordered pairs. First one I'll look at. See, I'm kind of I'd have to estimate this one right here, so I'm going to ignore that. But we'll kind of keep that in mind if we need some more accuracy. But I do have a clear one right here. We can see that for a second. That is 0, 1. We also have a clear point right here. That's 1, 2. And another clearly marked point right about here. That is 2, 4. Now this other point over here that I said we'll come back to, we can pretty much guess that it's about -1, 1/2. Oops, we'll move that back so that we can all see that. But we'll kind of use that more for accuracy because, you know, it could be close to 1/2. So we shall see. So if I'd like to graph the inverse now, for the inverse, I will just switch the x and y values. So for 0, 1, that becomes 1, 0. And we can plot them as we go. For 1, 2, that becomes 2, 1. 2, 4 becomes 4, 2. And if we're looking at the point we estimated, or we have a pretty good idea if we know exponential functions, we have a 1/2, -1. So 1/2, we estimate -1. So notice the very nice pattern f has with its inverse is it's always symmetric about the line y equals x. And so the line y equals x, if you remember, I'll draw that dashed the best I can. So we'll do our best to connect the points, understanding the symmetry. So we have this. Right, Laika? All right. So now we have the function graphed. That's f inverse. And we didn't even have to know what the equation was of the original function. So it's a very nice way, just in case you're ever analyzing graphs. I hope this helps. I'll see you in the next example.